Hey grade 7s, and welcome to this explainer on network basics and internet services. I want you to think for a second about what actually happens when you type a web address into your browser and smash that enter key. A web page pops up almost instantly, right? It honestly feels a lot like magic. But today, we're going to look behind the curtain and see exactly what's going on under the hood. There is a massive, completely invisible engine making that magic happen. And by the end of this explainer, you're going to know exactly how it all works.
Here's our roadmap for today. We're going to start by looking at clients and servers before exploring web protocols and DNS. Then, we'll learn the HTTP language and look at a real HTTP request in action. Finally, we'll wrap the whole thing up with a couple of knowledge checks and a quick lesson recap. All right, let's get into it. Section 1. Clients and servers. Who is talking on the web?
So, what actually happens when you type a web address? Let's dive right into this and map out the internet using a really simple analogy. I want you to think of the internet as a long road with two very distinct ends.
On one end of this road, you've got clients. Clients are just your everyday devices, like your laptop connected to Wi-Fi, or the phone in your pocket on a mobile network, running web browsers like Firefox or Chrome. In our analogy, the client is basically your house. You're sitting there deciding you want to place an order. On the exact opposite end of the road are the servers. Servers are these incredibly powerful computers that actually store all the web pages, sites, and apps. They hold all the code like HTML and the assets like images. So the server is like a massive shop that holds the goods you want to buy. When your client wants to access a web page, it makes a request to the server, and the server downloads a copy of those goods right back to your house, so your browser can display them for you.
Moving on to Section 2, Web Protocols and DNS. The rules of the road.
If the internet connection is the street between your house and the shop, well, we need some rules and tools to actually navigate it. The first absolutely vital tool here is TCP/IP, which stands for Transmission Control Protocol and Internet Protocol. Those sound super complicated, but they're really just the communication rules that define exactly how data travels back and forth across the internet. Going back to our road analogy, TCP/IP is your transport mechanism. It's literally the delivery truck or the bike that carries your order to the shop and then carries your goods safely back to your house. But wait, before that delivery truck can go anywhere, you actually have to know where the shop is, right? That is exactly where DNS comes in. DNS stands for the Domain Name System. See, when you type in a URL, a nice, easy-to-remember string of letters like mozilla.org, that's not the actual physical location of the server. Servers actually use these really complex numbers called IP addresses like 192.0.2.172. Because a random string of numbers like that is basically impossible for humans to memorize, DNS acts as the internet's handy address book. Your browser looks up the URL in the DNS to find the real IP address, so it knows exactly where to send your delivery truck. Now, when the server finally sends the web page back to you, it doesn't just chuck it at you in one giant, heavy package. Instead, data is sent across the web in multiple, super efficient small chunks, and we call these packets. Every single packet contains two main things. First, it has a header, which includes details like the client and server IP addresses, plus what number packet it is in the sequence. Second, it has a payload, and that contains the actual web page data being delivered to you. This brings us to a brilliant step-by-step cycle. Step 1. Your browser checks the DNS to find the server's actual IP address. Step 2. It sends a request message across the internet using our transport vehicle, TCP/IP. Step 3. If the server approves the request, it sends back a 200 OK message, which is basically it saying, yep, you can absolutely see this, and it starts sending over those tiny data packets. Step 4. Your browser catches all of those packets, snaps the chunks together like a giant puzzle, and displays the fully complete web page right in front of you.
All right, Section 3, the HTTP language. How clients and servers actually speak.
We know how the data travels, but what language are the house and the shop using to actually talk to each other? Well, they speak HTTP, or Hypertext Transfer Protocol. HTTP is an application protocol that defines the exact language clients and servers use to communicate. And the cool thing? It's incredibly simple and mostly human-readable. HTTP relies on a vocabulary of verbs, we call them request methods, to perform different actions. It's just like how you'd use specific action words to order different things at a store.
Let's talk about a few of these HTTP verbs. The get method is used to, well, get or retrieve data. Notice it's considered safe because it only asks for a copy of a file. It doesn't change or break anything on the server. On the flip side, the post method is used to submit data, like when you fill out an online form. This is definitely not considered safe because it can actually cause a change or a side effect on the server. Then there's the delete method, which, exactly as the name implies, deletes a specific resource. HTTP uses these exact verbs so the server knows exactly what the client is asking it to do, with zero confusion.
Section 4. A real HTTP request. Seen the engine in action.
Now, this is where it gets really interesting, because we're looking at the raw text of a real conversation. This is an actual HTTP request made by a browser. It simply says get/en/us/http2 and specifies the host as developer.mozilla.org. And honestly, that's the whole shebang. The client is just using that get verb to say, hey, please give me the English US homepage, and it's telling the server exactly which host it wants. It is remarkably straightforward. And boom, here is how the server responds back. First, it shoots over the status code 200, which, as we learned a second ago, is just the server saying, success, here is exactly what you asked for. Then it provides some headers, like content type text/HTML, telling the browser what kind of file to expect. Finally, after a blank line, it sends the payload. That's the actual HTML code starting with doctype HTML, which your browser will take and render into the visual web page you actually look at.
Section 5. Knowledge checks. Time to test your understanding.
Let's pause for just a second to make sure we're all on the same page here. Quick question for you. Is a URL like mozilla.org the actual, real location of a website on the internet? Think back to our analogy about the road in the address book. Got an answer? The answer is no. A URL is just a nice, easy-to-remember string for us humans. The actual, real location of a server on the internet is an IP address, which your browser has to go look up using the DNS. Okay, question 2. Based on the HTTP verbs we just talked about, which HTTP method should only retrieve data and not contain request content? Think about the safe and unsafe methods we went over. If you guess the GET method, you hit the nail on the head. The GET method is a completely safe method designed strictly for fetching a copy of a resource without altering anything on the server.
Finally, Section 6, Lesson Recap. Let's look at the big takeaways. Let's bring all these puzzle pieces together real quick. Clients, like your house, make requests, and servers, like the shop, deliver the goods. TCP/IP is the vehicle transporting your data back and forth. DNS, that's the address book translating human-friendly URLs into computer-friendly IP addresses. HTTP is the shared language of verbs used to actually place those orders. And lastly, files are never sent all at once. They travel safely and efficiently across the web, broken down into tiny packets.
Now that you understand the true mechanics behind the magic, I'll leave you with this final thought. A single modern web page is made up of HTML, dozens of images, CSS styling, and JavaScript files. Knowing that clients and servers use this exact HTTP engine to communicate, how many invisible HTTP requests and packets do you think are flying back and forth across the globe right now just by you loading up your favorite website? The scale is literally mind-boggling. Thanks for joining me for this Explainer Grade 7. Keep wondering how things work.